Hello and welcome to an episode of Let's Struggle with Rob. And today we're going to struggle our way through a Win32 buffer overflow using the PCman FTP program. So our setup today, our host machine is a Dell G7 with 32 gigs of RAM, a Core i7 processor running Windows 10, and VMware Workstation Pro 15. Inside Workstation Pro, we have a Windows 7 Service Pack 1 guest machine with the firewall disabled. It has 2 gigs of RAM. It's running the PCman FTP program, available at the link shown in case you want to follow along. And also running an Immunity Debugger, also available at the link shown. And then our attacking machine is a VM, a Kali Linux 2019.2 machine with 3 gigs of RAM and basically just a standard install. So we're going to be looking at registers a lot as we go through this today. These are the registers you'll see inside Immunity Debugger. The only ones we really need to concern ourselves with, at least for this demo, is the EIP, the extended instruction pointer, and that points to the address of the next instruction to be executed, and the ESP, which is the top of the stack and where we're going to eventually point our ESP to be able to run our shell code to exploit our victim. So a buffer overflow. Uh, in the simplest form, when a program is made that accepts input, they're going to assign a user buffer, and then that's going to be on one end of the memory stack. What an attacker does is they attempt to send way more input than the buffer is ready to accept, and that's going to overwrite the user buffer, it's going to overwrite the EIP and other items in the stack. So correctly handled, the program will sanitize the input and constrain the attacker's input to only the space allowed for the user buffer, in which case everything else in the stack remains safe and the program runs. The PCman FTP program we're using does not sanitize input, and so we have the ability to send an extremely long input when it's expecting a rather relatively short one, and it gives us the ability to not only overwrite the user buffer, but to just carry right on up the stack, overwrite the EIP, and other parts of the memory stack. So a properly crafted attack, well, will not only overwrite everything in the buffer, but we'll be able to replace the EIP with an address that we define ourselves, and then that address, of course, will point to our attacker shellcode, which we will put further down the memory. So, and once we've done that, when the EIP goes to see what's the next instruction to run, it's going to jump to our attack shellcode, and we are going to own the machine. Okay, so here's our Kali Linux that we're going to be attacking from, and here's our Win7 target running the PCman FTP server. So the first thing we need to do is called fuzzing, which is we need to find out if we can get the program to crash with too much input. I've pre-written a Fuzzer1 script. Let's pull it up here real quick. We're not really going to get too detailed into the code, other than to see that we're going to send a bunch of A's, 100 of them at first, as our username, and then we're just going to send the word pass as pass because we know it's going to fail. And we're going to, if that doesn't crash the program, we're going to add another 100 A's, and we're going to just keep looping until we've gotten to the point where we've sent 3,000 A's. We know it's going to crash long before that, so let's give this a run. Okay, and so we've sent 100 A's, 200 A's. Let's switch over. You can see on the FTP program as it scrolls by, accepting all the failed logins from us. And this is going to continue on for just a few more seconds here before we reach the point where we can crash the program by overwriting the EIP with A's, at which point it has nowhere to go and the program will halt. And that has happened now, as you can see, as our program seems to have paused. Let's switch back and look at our attack. Yeah, we have crashed the system. So at this point, we know that we are somewhere in the 2000, 2100A range before we can crash the program. So what we need to do is create a unique string that's at least 2100 characters long, and then be able to search that and see what ends up in the EIP. So we'll start out by making a copy of our Fuzzer script, and then we'll edit that. Okay. At this point, we can take out our while loop. We're not going to need that anymore, and we can eliminate the length, because we're going to have a set pattern that we're going to send to it. We're going to define the pattern here just as blank for right now, and then we'll be running a command in just a little bit here to create that pattern using the MSF console commands. So for right now, we're just cleaning up our script. We can get rid of everything here. And we're going to eliminate the A's, and we're just going to say we're going to send for the username our pattern that we're going to create. So, okay, let's open a new terminal, and then the command we want to run here is, user share metasploit framework tools exploits, or exploit, excuse me, and then we're going to do pattern create underscore create dot RB for Ruby. We're going to do -L for length, and then choose 2100 characters. I'm going to hit enter, and this will take just a few seconds to generate itself. Takes slightly longer running inside a VM than it does on bare metal. Okay, and now we have our unique pattern. We just need to copy this and then insert it into the pattern variable in our script. We'll just paste that in there, and we can save. Now at this point, we need our victim machine to not only be running the PCman program, but we need to fire up immunity as well, so that we can see what's going on with the registers. So the first thing we do is we go to File, Attach, and then we're going to search and find the PCman program here to attach to it. And then once that starts up, we just need to hit the play button to make sure that it's running. You can see in the lower right corner there it said running. Okay, now at this point we can run our Fuzzer2 script, and it's going to send that great big long string to the program. So now if we switch back over to our victim machine, we'll be able to see what's in the EIP register here. And we see it's 6F43376F. We're just going to copy that register or that selection and then go back to our attacking machine. Let's just cancel this Fuzzer 2. Okay, now we're going to run almost the same script as we did before, the user, share, Metasploit, framework, tools, exploit, pattern, and this time we'll do underscore offset to find out what the offset is. Then we're going to do -Q for query, and we'll paste in the value from that register. We'll hit enter, and it's going to come back and tell us that the offset we need to reach the EIP is 2002 characters. So we need 2002 characters to reach the start of the EIP register. So now let's copy our Fuzzer2 script and create a new one as Fuzzer3. And we're going to use that to make sure we can overwrite the EIP successfully. So at this point, we can get rid of our pattern. We're not going to need that anymore. And then in place of the pattern, what we're going to do is send the letter A, a capital A, and we know we need 2002 of those. And as you can see, I've done 2003, which is wrong, but we're going to leave that in there for right now so we can show you what happens when you're wrong. Then we're going to send 4 of the letter B, and that's what we want to overwrite our EIP. So our EIP address should say 42, 42, 42, 42, because that's the code for B. And then we're going to send 500 Cs just to fill up a bunch more space inside the buffer, just so we can see where we're at and where our Bs are sitting. So we'll save that. Let's switch back to our program and we'll do a restart to get everything running. You see it says paused in the lower right corner, so we'll hit play. And now it's running again. So now we can switch back to our attacking machine and we can send our Fuzzer3 script at it. Okay, and when we switch back, you can see our EIP now says 42, 42, 42, 41. So there's an A in our list of Bs. And that's how we can tell we've done something wrong with the EIP. So we're just going to restart this again. And then we're going to switch back and go back into our script. And we're going to go down to that 2003 A's, which I mistakenly put in there, and we're going to switch that back to 2002 A's. We'll hit save, and now we can run the program again. Make sure we're running first. Okay. And now when we switch back, we see the EIP is 42, 42, 42, 42, and the ESP is all C's. So we know that we can control the EIP and the ESP now. So we have a very good possibility of being able to overflow and get this to run our own malicious code. So what we did now is we click the little E button, and this shows us all of the running executables. What we look for is shell 32 DLL, and we're going to double click that. And then in this upper left quadrant, we're going to right click, and we're going to do a search for command. And what we're going to look for is JMP space ESP in all capitals. So we're going to go ahead and click find. And then we see it's in the upper corner there. We want to copy that address to the clipboard. That's going to be our return address. This is where we need to return to from our EIP. So at this point, let's go ahead and create our Fuzzer 4 Python script. We'll start by copying Fuzzer 3 and using, so we don't have to rewrite everything. Okay, so now we need to create some new things. First, let's just paste in that address that we need. So get rid of the extra junk here. And that's our return address. Okay, I'm going to go ahead and get things set up here. We need to restart the program again, but this time, after we attach, we do not want to click start. We want to right click in the upper left, do go to expression, and then paste in the address that we just copied in the last step. Just the address. We'll get rid of the extra junk here. And we hit OK to jump to it. And then we press F2 to set a breakpoint. So what we want is the program to run, but when it gets to this point, we want it to stop. And that's so we can verify that we're able to control the ESP and we're able to jump to it. So after that, we can click to get it running. Let's jump back and put together our Fuzzer 4 script. So we need to add in the return address. We'll just call it RET. And this needs to be written in a little endian format. So we're going to put it in with /x and then the two numbers, but this is done backwards. So our address ends with 28. So in little endian style, it starts with 28. And then we move up 2 and we have 6C. And then we move up 2, we have 37. And then we move to the beginning and we have 76. So this is how we write that out. So just leave ourselves a little comment here so we know what this is. And now, instead of sending 4 Bs in our user login section here, we're going to take that out and we're going to just send the return address. And we'll go ahead and save this script. And then we're all set. We can fire this off and see what happens to our to our victim machine. So here we go. And if we switch over now, we can see in the upper left corner, we indeed did stop at the address we put in there, which means we can control where the EIP is going to send the next execution. If we click this step into button here, we see it goes to the next step and it's all C's, which means we're sending it exactly to the space we control. So let's go ahead and just restart everything here. that running again. Now what we need to do is find bad characters. Bad characters are things like the X00, typically X00, X0A, X0D, and XFF are all bad characters because they represent things like line feed, carriage return, line break. And if you have those inside your shellcode script, the shellcode will quit executing at that point and it breaks your exploit. So what we're going to do here is we're going to create a bad character array that contains all of the possible values from 00 through FF. We're actually not going to put 00 in there because that's always a bad character, so you remove it. I'm just going to paste this in from elsewhere. If you do a search online, just look for shellcode bad characters and you'll find a post by Georgia Weedman that contains the entire bad character stack here, so you can just quickly cut and paste that in and not have to create everything. At this point then, we're going to send our 2002 A's, our return code, and then we're going to send our bad characters string. And it's going to break when it hits that first bad character, so we'll have to run this several times. So, okay, we'll save this. And now when we execute this, make sure everything's running. Yep, we're good. And now when we execute this, it's going to work as it did before. We're going to control the ESP. It's going to hit there, and then it's going to try and go to our bad characters. Okay, now when we switch back, you can see in the bottom right we have a whole bunch of A's. Those are the A's we sent. What we need to do is slide down to find the last of the A's. There they are. They're all 41s. And then you're going to see our return address after that as well, right here. And then you see we have the numbers 01, 02, 03, 04, 05, 06, 7, 8, 9, and then we go to 0A. But instead of 0A, we just have 00 because that is a bad byte or a bad character. So we know we need to get rid of 0A from our list of bad characters. So now that we know that character is bad, we can switch back to our script. Now let's restart here. Okay, so now we can go back into our script and we're going to find 0A in our list of bad characters that we're testing, and we're going to remove that from the list. We know it's bad, so we don't want to send that. And then we can save and we'll send this again. Okay, let's make sure we're running. No, we're paused, so let's run. Okay, now we're running. So we can send our Fuzzer script again. Okay, so now again we see our list of A's in the bottom right. We're going to scroll down, go through and find all of our A's. Okay, whoops. Okay, so there's all of our A's. Then we have our return address again, and then 01, 02, 03, 04, 05. And we keep going. Um, we don't have 0A anymore. We have 0B, 0C, but instead of 0D, we have 00 again. So we know we need to remove 0D from our list. So once again, we're going to go back and edit our Fuzzer script. And we'll just slide over to where it says X0D and get rid of that. Okay, now we can save this. All right, now we're all set to send it again. Let's get our program running. Okay. Now this time when we send it and we slide back and look at our victim, what we'll see is that the entire list has come through after the A's. There's no more 00s anywhere. There's no bad character. We start right off the bat here, 01, 02, 03, 04. And if we scroll through, we can see we have, uppercase, alphabet, lowercase. Everything is coming through just fine. When we get to the very bottom of the list where our FF is, just before back, you see there's our FF. There's the bad characters, 0D, 0A, 00. The ones we've removed are actually showing at the end as bad characters now. So now that we know what all the bad characters are, all we need to do is start the program on its own. We're done with immunity. And so now let's just copy our original, our Fuzzer 2 script. Um, and let's make an exploit script to allow us to take over the machine. So we'll copy Fuzzer 2 to exploit, and then we'll edit that. Okay. So now we just need to add in a few little things. We'll get rid of our pattern there. Okay, and we're gonna get rid of these 3 lines here because they just make our program kind of hang. We probably should have gotten rid of those long before now, but let's just get rid of those for now. Let's remove our pattern from what we're sending. So we're still going to send 2002 A's, and then we're going to send our return address, which we'll have to put in here. After the return address, we're going to send a buffer, which contains our payload. Actually, no, we're going to send a NOP sled, and then our buffer, which contains our payload. A NOP sled basically means no operation. When it sees /90 or in the instruction set, that tells the computer nothing to do here, keep moving. Just picture it like a snowy hill, and you start at the top with your sled, you go all the way down all the NOPs. That's the snow, and then you slide right into your exploit code at the end. This just provides a buffer for us in case we're off by 1 byte here or there with our shell code. This provides an easier way to slide into it. So we're just gonna copy in our return address from our last script so we don't have to type that all out. And then we need to set up our actual exploit code here. And we're going to put that in a buffer. So we're going to do buff equals, and then we're going to do B for byte. And then we're going to do double quotes, just two two double quotes. That just starts our buffer, and then buffer plus equals, and then that's going to be the start of each line. Buffer plus equals B, and then we're going to have our shell code. So we're going to generate our shell code using MSF Venom, and we're going to do a reverse shell so that we can control the victim machine from our attacking machine. And so, whoops, sorry about that, closed the wrong window. Let's just pop that open again, make it a little bigger. Okay, so our command to create our shellcode, MSF Venom. Then we're going to do -P for payload. We want Windows/shell to do a shell, and we're going to do _reverse because we're going to have the victim machine call us back, and _TCP because that's the type of connection it's going to be. Then we do lhost for localhost. That's the machine we're attacking from. And our IP is 192.168.1.16. And then we're going to do lport. And we're going to set that to 4444, just a standard one when using these shells. You could set it to 80 or whatever you needed to do to get around firewalls. We're going to set the exit function to thread because otherwise, once we connect, if you start typing, it would exit out and close your connection back. We're doing F for the file type. We're going to make this a C program, -A x86 because the architecture is 32-bit. And then we're going to do a -B and put in our bad characters. So we tell it basically, write me the script, but don't use any of these characters because it'll crash. So, and once we do that, we hit enter and let that chug for a little bit here while it scribbles out our code. And it should be popping up any second now. There we go. We just need to copy everything between the quotes. We're going to not take the semicolon at the end. So we're going to copy that. Now we just go back and we have our buff plus equals B, and then we're going to paste it right after that. And then we just need to add this buff plus equals B in front of each of the lines there so that we're adding them all together. And I'm sure there's a real nice fast way to do this, but I am just going to do a quick paste in and just throw it at the start of each line real quick here. And then once we have this ready, we should be all, we should be all set to execute this, and we should almost instantly have access to the victim machine, and we should be running as whomever the program's running at. In this case, that machine's name is Coyote, and the admin user's name is Bad Wolf. So if this works, we'll be on the machine as the admin, and we'll be able to create directories, delete things, do whatever we want. So now that our script is written and ready to go, we need to set up a listener for our reverse connections. We're going to do netcat -L for listen, V verbose, P for port. We're going to say port 4444, and we're just going to hit enter. I'll throw that in the background for a second here, and now we'll run our exploit. And you can see in the background, we are now in control of that machine. If I do who am I, we're the admin user bad wolf on machine coyote. If I want to make a directory, I could make a directory. We'll just call it you got hacked. And that works perfectly. If I switch to our victim machine, we're running inside the PCman folder. If we pop in here, whoops, it's actually in here as Pacman, not PCman. But if we open that folder, we can see there's the you got hacked folder that we just created. And with that, we have owned this machine and mastered the Win32 buffer overflow.